what purpose does attic and roof ventilation serve? Okay, the first and most important is it vents the roof deck and has a drying effect on the roof deck. So the roof sheathing or the roof deck is very vulnerable to moisture. It has shingles and tar paper on the top, and sometimes it's also has insulation very close to its bottom. So there is a problem oftentimes with the roof deck drying out if it gets wet. And you know, eventually roof decks get wet. So this is really what we're looking for here. We've got to accomplish this with our attic and roof ventilation. We also want to exert a drying effect on the insulation should it get wet. And does insulation get wet in attics and in roof cavities? Yes, unfortunately it does. Then it has a cooling effect. Ventilation has a cooling effect on the roof deck, and that prevents ice dams by keeping the entire roof cold. I mean, if the roof is cold, then the snow that is there just remains there until the outdoor temperature comes up and melts the snow evenly along the roof. If you have air leaks in the attic and it warms the bottom of the roof deck, then you have melting in one place and the water flowing down and you know, coming to the edge of the roof, freezing again, and this is a problem. Large icicles hanging from the edge of the roof. So we want to prevent that by keeping the roof deck cool. We can also reduce roof solar gain in the summertime. And that's a very good thing for us to do because roof solar gain is one of the main components of our need for air conditioning. So we can reduce that effect. We want the attic and roof ventilation to facilitate a good insulation detail. So we have to think about the insulation because we'd like the insulation to come all the way out over top of the outside wall, over top of that exterior wall. Not many houses have a very good detail right there. And so we'll talk about that. And also, where we live in a climate where there's a lot of driving rain, a lot of wind, a lot of snow, we want to keep out the rain and the snow. We don't want the rain and the snow to come, you know, roaring in through the vents and wet the attic insulation or wet roof insulation or just deposit a lot of snow in your attic. And, you know, that kind of thing happens all the time too. So let's look at some diagrams and talk about what we want in terms of the details of attic insulation. So in cold climates, this is what we're trying to avoid with roof ventilation. Here we have a soffit with no vents. We have the insulation coming right up and touching the roof deck here. So the roof deck has no ventilation. And we have heat transmission, we have some air leakage happening in the wintertime, and we have melting. And the melting snow in the form of water runs right underneath the snow. When it gets to the edge here, it freezes. Why does it freeze at the edge? Well, you know the signs that they have on the highways in cold climates, bridge freezes before road surface. And the reason why the bridge freezes before the road surface is because the air gets underneath the bridge and makes it colder than the regular road surface, which is attached to the ground. So that's what happens here. We got cold air underneath here, which makes this part of the roof colder. So when the water hits this part of the roof, it freezes. And you get a bunch of freezing and thawing here, and you get a big load of ice, you know, hundreds of pounds of ice sometimes here on the roof edge, and a freezing and thawing action, which ends up tearing up the shingles, dampening the roof deck, maybe making its way down in the walls, a real mess of a situation and has, severely damaged many, many homes and continues to. Let's continue our conversation about attic ventilation by looking at how we ventilate the underneath of the roof deck. So this illustration right here shows us that we've got the outdoor air coming in through the soffit and traveling up through the attic, because we have the attic insulation right here. So this is an attic and the insulation is at the ceiling. And so this air follows up on the roof deck, and the outdoor air in the wintertime is keeping the roof deck cold. And so that's important so we don't get ice damming. And it's flowing against the roof deck and could be carrying moisture away from the roof deck that may have become damp somehow. For example, if we had vapor diffusion or air leakage coming up here and we had the roof deck being cold, well, there would be some condensation, and there often is condensation at the underside of the roof deck during cold weather. So it's important that we have some ventilation to dry out that roof deck. So the outdoor air comes in and it comes out up here at the ridge vent. Many ridge vents allow you to shingle over the top of it, so they're kind of invisible, and that's what you see here. The air is coming out the roof vent, but we have a problem in that this area right here is hard to ventilate, because the air comes in here, but it doesn't really, it's really kind of bound up here, and these areas up here don't get well ventilated. Now, if we're building a new house, we can install some devices that will allow the air to cross over into these areas. That's probably a good thing to do if we want to ventilate from underneath the roof deck. Okay, now let's look at another example where instead of the attic being insulated, the attic is now finished. And so we have the insulation at the roof between the rafters, and here we have a baffle that gives us an airspace. The building code says the airspace can be an inch wide, but the EPA says the airspace should be more like 2 inches wide. So take that under consideration. So again, we've got the outdoor air coming up, circulating underneath the roof deck and coming out of the ridge vent. And the disadvantage to insulating the roof is a lot of times you don't have adequate space to put as much insulation as you'd like to put in there. If the roof dead ends into a wall, as many roofs do, we can install a device like this that allows the ventilation air to travel up here against the roof deck, come out of a slot here, and then travel out. Again, it would be entering with soffit vents, either continuous soffit vents or discrete soffit vents. That's how we're ventilating attics from the underneath. Let's look at some of the details of the soffit venting. Here you see a detail of the soffit venting, and we have just individual soffit vents, and the air is traveling up here, and we have this baffle or chute right here that directs the air over top of the insulation. We don't want wind to be blowing into a soffit vent and blowing right into the fibrous insulation, because the fibrous insulation is not an air barrier, and we can get wind washing, and we can get a big area of thermal bridging in here, which, you know, unfortunately we have anyways with a lot of homes because we don't have enough height here to get the full depth that we'd like of insulation all the way over here on top of the exterior wall. So the chute serves a good purpose, and we have here a continuous soffit vent. So we just put usually 2 layers of, say, 3/8 inch plywood fastened to the bottom of the trusses, and we have a space in between them about this big, and this soffit vent is kind of pinned to the bottoms of the trusses against this flange here. And then here we have a continuous soffit vent that is just a steel soffit. And you know, it's part of a system of maybe steel siding or vinyl siding where we're trying to really have kind of a very, very low maintenance exterior. Now, in a climate where we may get wind-driven rain and wind-driven snow, we could have something like this fascia vent right here. And we get airflow coming in these small openings and coming up and then able to make its way against the bottom of the sheathing up to the ridge vent. And there's a number of different types of systems that you can buy if you happen to be in an area that has a lot of wind and rain, and you don't want to have your insulation and your structural members wetted by that rain that can blow right into those soffit vents. So that's the story of ventilating below the roof deck. Now there's another choice that you have. You can ventilate above the roof deck. And so we can go above the roof deck, but ideally what we want in terms of this underlayment is something that transmits water vapor very well, that has a very high perm rating. And you can get underlayment, special underlayment that has a very high perm rating. And you know, with shingles like this, or really with any kind of shingles, I mean, if you get up on a roof after it's been raining, you know, for days in any climate, I mean, the roof has soaked up quite a bit of water. So, I mean, you've got to have this underlayment here, and it's got to be waterproof. It's part of the home's water-resistive barrier. But in this kind of a situation, and really I prefer it in almost any situation, is to have some roof underlayment here that is very permeable to water vapor, something on the order of you know, 50 to 200 perms would be kind of a measurement if you were looking for that. And a perm is a measurement of how permeable a material is, and the higher the perm rating, the more permeable it is. You want a vapor permeable. So then when you have, you can see here that this is another kind of a fascia roof vent. So the air goes into the fascia and it goes underneath. I call this wiggle board. You know, it's kind of a strip that has you know, spaces underneath it, and it serves as an anchor for these shingles, these tile shingles. And so we have the roof deck being ventilated. And really the thing I like about this, especially in the warm climates, is you've really cut off the shingles from being as much of a conduit for solar heat into the home by ventilating underneath them. You know, you choose white shingles ventilated like this, and I mean, your air conditioning costs are going to be 15 or 20% lower than your neighbor's who has a dark colored roof and no ventilation under the shingles. So very, very good detail for both keeping a roof dry and for blocking a lot of solar heat from coming in the house. This is a more traditional way of doing it. We have 2 layers of furring. And so the first layer of furring goes in this direction, and that's going to let any water that gets through the shingles be able to drain out and not be blocked by the horizontal pieces. But you need the horizontal pieces to fasten the shingles to. And here we're working with, you know, different types of pretty stiff shingles or a metal roof. That's the way that that's done. So then we need some way in the soffit area here for the air to get up into these cavities and run, you know, up here along the roof deck and underneath the shingles. And again, we have the same kind of benefit here of, you know, turning back a lot of solar heat. Even if these shingles are dark, we're going to reduce the solar heat quite a bit. But if you have like a white tile roofing or white metal roofing and you know, a detail like this, you're going to have a very, very cool roof and a very comfortable home. Going to block a lot of solar heat. And then we have some of the newer materials where we have a material that has a lot of air spaces in it. And then we're installing metal roofing over top of that. And so the air is going to travel under the metal roofing and over the top of this material, which is going to draw moisture, if there happens to be any, out of the roof decking. So this material here is very, very vapor permeable. We want it to be very vapor permeable. And, you know, metal roofing is an excellent choice. I mean, there's metal roofing you can buy just about anywhere that's guaranteed for 50 years. And very, very good roofing, especially white colored if you live in a warm climate where you're air conditioning. Saves a lot on air conditioning. Okay, remember that our attic and roof ventilation, we want ventilation either on top of the roof deck or underneath the roof deck. And that's to keep the roof deck dry. We don't want our roof deck to get soft and mushy. That's a real problem. Then we want our insulation to stay dry. We also want to be able to install as much insulation as possible there right at the eaves over top of the exterior wall. If we're building new, that's going to be very important. If we're retrofitting, maybe we'll use foam insulation there right over top of the wall, because the foam insulation has a higher R value per inch. It's good in that area. We want the roof deck to stay cool, both because that prevents ice dams and because it can block solar heat. We want to keep the rain and snow out, and so if we have driving rain or driving snow, we might choose an innovative type of roof venting system that would prevent the snow and rain from getting into the attic or getting into the roof cavity.